masterclass with me. If you have any questions, please leave them in the chat as well. Dennis, would you like to say a few bits about yourself before we start the masterclass?
Yeah, there's sort of an entire slide, and I feel humble enough not to read all this for myself, so you guys please just enjoy a little reading. Long story short, yeah, over 10 years in DevOps engineering and running Corewide and all that. I hope to get to showcase some of this experience today and help you guys out on understanding all the AWS intricacies and generally architecting the infrastructure. But yeah, I don't think it's worth mentioning more than what you can already see, and let's instead focus on the topic later on.
Okay, sounds good, Dennis. Right then, it looks like we've got 16 people on the call. We still wait another 2 minutes. I can see, yeah, I can see Leon. Thanks for joining us. Yeah, so the way these things run is if you have any questions about what Dennis is going to be sharing, and Alexandra as well, you can leave them in the chat, and then we're going to take them on later in the Q&A section. Okay. Okay. Right, let's wait another 2 minutes and then let's get started. Okay, thanks for joining, Maxime. Okay, so where your time is valuable, everyone. So let's perhaps do a kickoff and start the masterclass in this case. Dennis, over to you.
Thank you, Aziz. So most of the clients Corewide works with are startups and medium-sized businesses that have their application and they wanted to, well, get to the cloud. Why cloud? Well, the obvious reasons, all of the reliability, everything, all of the buzzwords that you ever heard, they're probably applicable to cloud and everybody wants to get them. So when it comes to actually developing an application, practically everybody puts a lot of thoughts, a lot of architecting, design, and the ideas and the implementation of the business logic always goes first. So that is an interesting scenario because when it comes to deploying the application, that gets somewhere further down the line, then people are trying to find engineers to deploy this or make the people learn the ropes in all the cloud engineering. And then comes the biggest question of, so when can we get this? When, like, what's the time frame? And we typically say that depends, right? So the goal of this particular call is to get a grasp of what a good infrastructure looks like. And at the same time, try to answer this particular question: can your next infrastructure setup take less time than this presentation? Because let's be honest, usually this is the case where you just say, no, not without the shortcuts. And shortcuts is something that will backfire. So let's break down the whole concept of infrastructure and the architecture of the cloud and what we can take away from this. So the only assumption I am going to make is that you have heard something about the cloud as the idea. You have your application or software business that you want to deliver to the cloud, and you want this to go well. So you have some concerns and some challenges, well, definitely listed here. But first of all, you want this to be reliable because for you, the infrastructure is something you don't want to care about. And I don't mean you don't want to take care of it. I mean, you really don't want to care about it. All you want from it is that your app just runs somewhere out there in the infrastructure as a concept, right? That somebody implemented for you or you did. So you want this to be reliable and stable. Let it not crash and you're satisfied. And you also want it to be secure because, hey, it's going to, well, obviously, going to attract a lot of people. And some of that attention might be malicious. And you want to get away from that. And you want to stick to the compliance bits. You want your application, your entire business and the project to be secure, compliant enough so you can get well-worn clients to trust you, which means it has to be pretty tight. And to implement all this, you need the expertise. Not particularly you, maybe, your team, the partners, whoever this is. But the expertise is important because if you start with something that you don't really have an expertise and learn the ropes as you go, somewhere down the line, you look back and think, this did not go well. And you have to redo something. This generally creates technical debt that, again, let me be honest, not a lot of people actually address. So either something breaks and you have to address it, or you just hope for the best, which is never a good strategy. Eventually, people end up with redoing the entire thing just because the team who had implemented this outgrown the system and realized that, yeah, we can do it better, but it will take revamping the entire thing. These things happen. Can you avoid them in advance? Can you think ahead? I think you should, and I hope to help with that one. So all these things combined, they're never cheap. I mean, yeah, there's this famous triangle of your budget, of your performance, and the speed, and you cannot ever take all three. So costs and budgets are important. You don't really want to spend a lot of money that you would rather direct somewhere else, like marketing your application, developing it further, engaging with your end customers. So things like that, you can always know where to put money. But just delivering the application, starting to roll this out isn't enough. Like, I think everybody heard the famous historical idea of you can capture the city, but can you hold it? This also is very applicable to the application going to production. Once you release this, what's next? It can break, you have to support it, you have to buy some maintenance, and there's also upkeep involved. And all of these things also come with the burden of knowledge beside the expertise. You have to be aware of what is going on with your infra at any moment in time for the maintenance to go well, for you to be able to support it, for the teams to be able to support it. And your general probably intention is to just, I don't know, put it on someone else's shoulders. Or if you have to be the one responsible for it, at least understand enough to be able to take action. However, in the end of the day, you still do not want to care about infrastructure. Hell, I'm working with infrastructure daily. Half the time, I don't want to care about it. And I have to. And you as the business owner and I as the vendor representative, let's say, would really want to sleep soundly in the night without worrying that at this point, something might go not that well. So what do we do about it? We plan well, we think ahead, and we're trying to understand the building blocks of what makes a really good infrastructure that helps address all of these challenges. Today, we're focusing on AWS, but effectively, most of the concepts really apply to any other cloud provider. Big, small, doesn't really matter. The whole point is to, again, understand the concept and then just learn how it's called in another cloud. Some of the cloud providers offer specific services and unavailable in others, but they keep the parity most of the time. So starting out, I would stick to one single idea right now. We have the cloud as the concept of abstracting the resources from you. Long gone are the days when people were deploying software directly to the servers. Like everything is servers. You have the services, you have the clouds. Again, plenty of buzzwords, but what do they really mean? All they mean is that somebody else took a bunch of engineers, put them behind the servers that they managed, and then, they simply built an interface for you to click through and get the result you want, but not the resources for that result. if that makes sense. So I like to break down infrastructures and architectures into layers. Layers because every next layer depends on the previous one. And we'll start from the bottom and we'll go up. So the bottom layer is the networking. This is where we're going to isolate all of the resources that we're going to have for our infrastructure. The whole point, again, is to get the app running, but getting the app requires a lot of under the hood adjustments on the infra level. So let's start with the network. In most clouds, there's the concept of VPC, virtual private cloud. This is networking. Imagine somebody took your home router and just put it somewhere out there, out of your reach, but still gave you the interface to manage it. This is your VPC. It handles a bunch of networks, as many as you like to create. And you could put those services that you're going to use into every little subnet out there. And you can make them work together or not work together, more importantly, because not everything in your infrastructure is going to connect to one another. A good example would be your app that is going to connect to your database. And there's going to be some specific service in your app that is not going to connect to the database, and it has to be isolated. And ideally, you would want to have control over all of this. So VPCs give you the segmentation. The way you place things is up to you. However, this is the main building block because you cannot go further without. Next up is you have to lead the people to your application. This is probably the most familiar concept to you. You guys come up with cool names for the domains every day. You need something snappy, you need something short, something that people will remember. Nobody really cares what's going on under them. In practice, DNS is something that translates your catchy domain name into that service address that you're actually using in the cloud or a server. Does not really matter. So once you establish that, you get your domain to, well, in this case, AWS. You can start leading the traffic in, and something has to capture it. Something has to take it, route it to your app. I keep saying application, meaning your specific project. However, applications currently, most of the time, are pretty complex things. There can be microservices, there can be multi-component pieces where there's one thing doing one specific task and the other one doing another, and then you have a whole bunch of them, and then for a dozen instances of each, we'll get there. The whole idea is that we get the traffic and we'll let something distributed to multiple copies of your app. We need to expect redundancy right away. In this day and age, it feels like a loss when a single more second is spent by the visitor waiting for your page to load. They will not care enough to wait. They will probably close the tab. So what you want is to get them that page as fast as possible and as reliably as possible. So what if at this moment you have a spike of traffic or there's an update going on under the hood? You don't really want them to see that maintenance page that everybody places. You want them to still have the experience of your application because this is the most important part for your business. So you need to keep redundancy. You have to keep multiple copies of everything. And then there's some endpoint, which is the load balancer that I'm talking about, that is going to accept the traffic and distribute it between these copies. What connects all of these pieces together and actually allows you to define that this traffic is accepted from public internet, this one is isolated privately, these services can talk to one another, and these can't, is the firewall. In AWS, firewall is called security groups. And that's exactly what it is. You place the services that have to have very specific rule set of access. One security group, you place others to another, and you connect them as you please. So eventually, this is your baseline. Once you have all these, you can start thinking about the next level. The next level is storage, storing your data. It's fairly rarely that the application does not process or store any sort of data. Most of the apps need some storage for the media, some database for the data. Very few applications actually need nothing, because they just process data and deliver it somewhere as part of the pipeline. But most of the time, you need various kinds of storage. And storage is the thing that when it goes wrong, you're basically losing your data and your customers' data. So it has to be reliable, it has to be sufficient for all of your needs, and still quite manageable. Again, without the cloud, you would have to spin up a server, deploy the software with your database on it, right? And then maintain it, take care of the upgrades and all of that. Clouds give you something else instead. They give you the service, give you the software that you want, the access point to it, and you can decide what sort of resources you want for this service to have. So the databases in AWS are RDS. If you want MySQL, PostgreSQL, any sort of SQL, this is where it goes. This is where you can get MySQL without the burden of a server. I mean, it is somewhere out there, but you don't really have to bother. Next up, what else? Pretty common scenario. You have the data, you can access it, you access it frequently enough to start the database gears spinning, and then you're thinking, okay, with the increased load, I have to increase the database size because, well, it starts lagging. So instead of handling that slowdown by throwing money at your database service, you think wiser and you're, okay, we're introducing the caching layer. So you teach your application to cache some of the data from the database into some service like Elasticache, where it resides. It's a lot more, a lot less expensive, and it's also pretty convenient to have a service that is dedicated strictly to that. Next up, your users will upload some things, even basic avatars, and you cannot predict how many of them there will be. The documents that they store, the media files, practically every little piece of file that they will have, they will store somewhere. So you would ideally want to just have the endpoint where your application just throws the data there, it stays there, and you don't, again, you're not bothered with it. You know that it's always there, it's versioned, backup, all of that. Object storage, S3 in particular in AWS, this is the answer. It's virtually unlimited, it is geographically distributed, it is virtually impossible to crash. I mean, honestly, I would like to see somebody do it. So you can store practically anything there, as long as your application can have access to S3 and you create the bucket. The last piece, but not the least, is addressing the sensitive data in your setup. So on one hand, you have all of the passwords to the infrastructure related things, right? Your app will access the database to make it securely. We'll have a secure connection, but we'll also have the username and the password, and you can give it to the application as a matter of configuration, but you have to store it somewhere. The best case is having the secret manager in AWS, where you store those passwords and then your app will get access to them. Most importantly, you can store the data that AWS has, well, no idea about. For example, most of the apps have some sort of integration, basic login with another provider, for example. And for that, you will have to use some API token to a third-party service. And storing that token for the app to be available is exactly the goal of the AWS Secrets Manager. You throw some data in there, it is encrypted, and it is there for the app to consume. All of these services, besides abstracting the server idea from you, also take care about the backups, about the redundancy. You can make them highly available. The term that basically applies that there's at least one more copy of the same setup that you're running, the same database, for example, but in a different data center. So in a very rare occasion that AWS crashes one of their data centers, your data is still available from another one. We're kind of done with this layer. Now you have the networking. Now you have the data layer. You have things ready for your app to work with, but where's the end? So time to pick the most crucial thing, something that will run your app. The obvious choice would be to go with something like EC2 and just basically rent a virtual server from AWS. For a simple scenario where you're just developing things, that might be okay. However, again, this always comes with the idea of managing things. And cloud is exactly the opposite of that. It's about managing them for you. So what you're looking for is the service from the cloud that you can tell, look, I have an app, just run it and let my load balancer connect to this app. I don't want anything else. In reality, you want a little bit more. You want all of the resilience. You want all the scalability. What I mean by that? Resilience is when your app crashes, what should happen? It shouldn't stay crashed. It should restart. Something should recover it. In a server environment, you kind of take care of this yourself. You're writing stuff that will monitor your stuff, to wake it if it sleeps, to restart it if it dies, things like that. In a cloud environment, there is preset environment like that takes care of it. Most of the server applications nowadays have the idea of containerization, basically putting your app in a box and letting that box be run virtually anywhere. And there are things called container orchestrators that run your containers with your apps in as many copies as necessary. Why even consider this, first of all? You probably heard of Kubernetes. If you haven't, I wonder why. Plenty of people are using Kubernetes in production for a lot of years already. Besides, again, being another buzzword, it's an actually interesting and reliable technology at the moment that comes with, first of all, a set of really, really cool benefits that I will explain just right away. But it kind of requires you to have a specific threshold of entry. Like, you have to understand a lot of intricacies underneath it. At least this is what I thought when I first started working. Sometimes later, I'm thinking, like, why people think it's difficult or complex or something. I think the lack of knowledge and at least in my opinion, I think it's because the engineering people are trying very, very hard to innovate. One of the critical points about your apps as software businesses is that you tend to lead the innovation and bring the industry forward. You're always doing something new that hasn't been done before. You're bringing new tech, you're bringing new ideas. But from the infrastructure, you always want it to be the same, to be stable, to be reliable, to be something that wouldn't crash just because it's new and raw. So Kubernetes under the hood is a pretty complex system, but its functionality is actually very straightforward and understandable. So if you had a choice between having multiple servers, having to deploy your app on each and every one of them, or having some sort of software that you tell, I want this app to run this many times at the same time, what would you pick? I think the answer is obvious. You would take the second one, which is Kubernetes, actually. So instead of, again, working with the machines and all that, you have the orchestrator that you specify the state of the app that you want. Say you have a dozen microservices. Some of them are smallish things that don't really do much. And then you have a bunch of those that experience a lot of traffic incoming, and they need to process it, let's say, in different ways, depending on the flow. So when there's a traffic spike, you want this to be handled. But if a single application cannot survive the traffic spike, multiple would. Kubernetes will be the thing that will take care of it. Now, explaining it simply, Kubernetes is the thing that can get you more virtual machines and put your application on each and every one of them as many times as needed to handle the traffic. Say you have in the 24 hours, you have 8 hours of really, really intense traffic. So Kubernetes will be able to get you multiple machines during that time. And when the traffic is off peak and you really don't have a lot of activity going on, it will shrink back to 1 or 2 machines, saving you money, saving you resources. And it will do this at the route that you specify, or even automatic. To make that traffic that goes through the load balancer hit your Kubernetes, there should be a component inside Kubernetes cluster, which is called ingress. This is what routes the traffic, depending on the domain, the paths, the URLs, all of that between your apps. Say you have, again, multiple microservices. One of them is responsible for account activity. The other one handles the data processing and so on. They have different routes, and ingress will be the one to decide which one goes where. And if one of them is not available, it will quickly reroute stuff to another copy of the same service. Very effective. Speaking of scaling, the thing I said before that Kubernetes scales the nodes, the actual service. How does it do it? It needs to understand how many copies of the app need to be placed. Then it calculates, okay, I have, let's say, 10 servers with maybe 8 gigs of RAM on each, and all of my apps combined together consume 80 gigs of RAM, plus some others that need extra. So you run out of resources. So Kubernetes says, okay, cloud, come here, give me more machines, and then it schedules the new apps to those machines. However, there is an important point about deciding how many app copies we actually need. So there's autoscaling on the node level, and then there's autoscaling on the app level. The typical scenario is, hey, it uses some amount of CPU, it uses some amount of RAM. If it hits this specific threshold, let's scale it. I mean, plain and simple, people have been doing this for ages. But not everything works this way. A typical example would be an app that actually processes stuff from the queue. You have a queue lined up. I don't know, maybe some media processing, right? There's an app in your stack that accepts the request from the client, places an item into the queue, and waits for the next request. And then there's a worker in your system that constantly monitors that queue, and if there's a new item, it picks it up and processes it. What happens when you have a traffic spike? You have a lot of people coming in, they're all uploading their files for the conversion, and you get the queue extended. And you only have a single worker, and that worker will choke on that for sure. And your customers will not get the converted files as they need. So you would really want to scale the workers, not based on the load in CPU or RAM that they want, but based on the number of items in that queue, which is effectively event-driven pattern. Like there's an event placing an item in the queue, and then the idea of consuming that item and working with it. This is one of the many examples where event-driven autoscaling really, really shines. And the component that we can place inside the cluster is called Kubernetes event-driven autoscaling. Works really well for design patterns besides the generic resource. What else is there? You don't really want your app to consume the sensitive data that you placed into Secrets Manager directly. I mean, you will have to give it the permissions to go to the cloud level, get the secrets from the Secrets Manager, which means that if something were to maybe go through a vulnerability inside your application, it will also have the same level of access. It will be able to go to the Secrets Manager and fetch the data on its own. And you would definitely not want that. What if we have the infrastructure to do something that the app shouldn't? Like in my head, the ideal app is the one that does its job, does it well, and doesn't care about anything else. The whole purpose of your app is your business logic. So fetching data from somewhere for its configuration is not the part of its purpose. This is something that the infrastructure should do. So we place another component inside the cluster called external secret operator that gets your data from the secrets and places it as the configuration for the app. So now we have 3 layers. We have the network, we have the data layer, we have the orchestrator to actually work with the app. Where's the app? Let's place the app there. As I said before, containerization is like all over the place. We're placing everything into boxes. We deliver those boxes. Where do we store the boxes? The boxes are the images. This is where we bake the app, the dependencies, all the little libraries that it needs. And we store it in a registry. In AWS, this registry is called ECR. Elastic, they really like this word, Elastic Container Registry. So this is the first component where we store the images. Every new release of your app or the microservice or the component is just a new image that is placed into ECR. When Kubernetes needs to run your new version, it just pulls the data from ECR and runs it. When there's something off, you need to roll back, it just pulls the previous version and runs this instead. Easy and very, very fast. But there should be something that would create those images and place them into the ECR. Normally, you would want this to be a CI/CD platform, like continuous integration, continuous delivery, the whole pipeline that gets your from the code to the delivery. And CI/CD platforms are usually tied to the source code management system. This is your GitLab, GitHub, Bitbucket, and all the others. And they all have their platform for the CI/CD and the pipelines functionality. And then you're thinking, so you're paying for a plan in GitLab or GitHub, and you get some number of minutes or specific resources to spend on your pipelines. And you can run out of them because during the intense phase of the development, there can be a lot of builds, a lot of deployments. Things can go all sorts of crazy, and you will run out of minutes and you will have to pay more to the CI/CD platform all to get more builds. But practically all of them allow you to take the matter into your own hands. You can deploy the CI/CD runner back into your cluster next to your application, which gives you all of the control around the builds, around the deployments, all of the caching things. Another thing of big importance, I think, is that the only thing at this point that the source code management system has is your code. None of the builds, none of the artifacts, none of the build logs are actually getting to the third party. It is in your infrastructure, it is stored there, it is kept there. And you decide how much you pay for it, what resources it has, and you don't have a limited number of minutes to spend on the builds, most of the time, depending on the platform. So yeah, we place the runner into your cluster next to your app, so it is more convenient to deploy it. And you're not limited anymore. What's left is to treat the actual infrastructure the same way you treat the app. Because why not? Think about it. I described up to this point 4 layers of infrastructure components with at least 3 pieces in each. There's a lot of nuances, a lot of parameters, a lot of cross references, similar naming, things that you just have to be aware of. Now imagine 1, 2, a bunch of people going through AWS interface, clicking through it, creating all of these resources. It will look like a mess. Not because it's bad or something, just because there's plenty of it. And it is really, really difficult to manage it. You need to be able to grasp the things. You start, maybe in the best case scenario, you start drawing diagrams and writing the documentation, which admittedly is something people rarely do unless they're at the gunpoint. More on that later. So you need a way to make sure that if something happens, first of all, you can easily troubleshoot it. You can find the faulty component in the infrastructure and recover it. Maybe change a little configuration, maybe just one single checkbox, but you need to find it. You need to know where it is. And you need to know what other components will be affected. As long as you keep in your head the idea of the layers and the services that are there, you might be able to succeed fairly fast. What if it's some sort of critical disaster and you will have to recreate the entire infrastructure from scratch? I wouldn't really hope anybody to end up in this situation, but it is really cumbersome. What's most important is that you're using your audience, the visitors, and the app functionality. It might be a reputation hit that the company never recovers from. So what do we do about it? People write disaster recovery plans. This is the plan of action to restore things to a specific state. Now, think about it. Up until this point, we have automated fairly anything. The whole idea of the DevOps is to bring in different teams with different functionalities together and automating the processes and tech. What can we do about this on the infrastructure level? There's an entire concept called infrastructure as code. All of these resources, all of these services, well, all of their parameters, what you want is the state of them. And you want to describe that state in the code. And then you apply that state as a deployment, just like you would with any other app. And it changes what you have in the cloud. You described in the code the resource that creates your database cluster. You apply it, you have your database cluster. Somebody changed, maybe by accident, the size of that machine. You can revert it back just by applying the latest state. Whenever something needs to change, grow, extend, you first describe it in a code, you apply this, and the state is changed. And then you can work with it as your disaster recovery tool as well. If something happened, you can always revert it. Any sort of change is also tracked. So for the compliance reasons, it's very important to audit your things. And whenever a change is introduced, if you can reproduce it or can get back to the point in time in history effectively where it was introduced, you're golden. You have your means of disaster recovery. Backups aside, of course, this is about the state of the infra. So applying those changes in the state can also be done automatically. And you would really like it to behave the same way as you do with your application. You want to basically release it. You want to have specific versions of your app deployed at your convenience automatically. Same goes about the. So what's left is there. Remember I told you about conquering the city and then holding it together. Now you have a shiny new infrastructure. It just works until it doesn't. Nothing is perfect. Things happen. You get upgrades. You get outages. Things happen, and you need to be able to address them. However, from what I know, you cannot address things unless you know about them. So awareness is something you have to build into your infrastructure. Awareness for you. So how is that achieved? By introducing the concept of observability. It's effectively a set of monitoring tools that are combined together to give you the proper information about everything that is going on with your infra and the application. How it's done? Like every app generates some sort of activity. All the events are printed in the logs, and the logs can be collected somewhere. So over the years, we have adopted a practice of using the monitoring tools that fit best for the specific application. It's generally a good idea to pick the tool that is, well, most suited for your stack. So for containers and containerized applications, there's a stack of Loki, Prometheus, and Grafana. So Loki is the component that stores all the logs, unless you then query them with the historical perspective. Like you can get back to, I don't know, 3 months ago and check the logs of what was happening, which is very important to, at the worst, writing postmortems, at the best, tracking down a bug that happened right away and you need to apply the hotfix, but you don't really know what was happening. You can check that from the logs. There's important distinguishing factor about the logs is that they show you what happened, but they do not show you the state of the other components in the system. Think about it. When the application throws an error saying there is overload, like I cannot get the access to the database due to timeout, you would really want to know what is happening with the database at that point. How would you get this? You need numbers. You need the number of connections. You need the disk pressure. You need the usage of RAM. Where do you get all these numbers? These numbers are metrics. So everything that is going on with your infra, workloads, and everything else can generate a metric, and there should be something to collect that metric. The same way it works for the logs. So here comes Prometheus. Prometheus is virtually the same thing as Loki. It just collects metrics instead. Metrics get stored in its own database of Prometheus, but of Prometheus actually. And you can get the data from there. Both of these apps are really good at what they do and nothing else. They're bad at visualizing stuff. you can get basic chart from the Prometheus, but it will never be the level of what you would be proudly placing on your monitor next to you, where you're checking the state of the infra. For that, there's another shop called Grafana. Grafana is the master of running queries in practically everything, including locking Prometheus, getting the data, and displaying it as beautiful charts, dashboards. Like, one important point, no affiliation with this guy, although I really, really like the software and recommend it practically everywhere. So Grafana can get you pretty dashboards, panels, but what's most important is that they are useful. You can display there exactly the things that you want to have, the things that you want to track, and you can assign alerts there. This is the source of your sound sleep. If there's an application that is misbehaving and you have the alert for it, Grafana will send it to you, a notification to your Slack, your messenger of choice, email. It can call you through PagerDuty, plenty of options. The fact that Grafana can integrate them and gives you the single source of truth about the state of the infrastructure deployed gives you that, well, good awareness that you were lacking before. The good monitoring system can be the difference between the application that is stable and the application that is stable and you know where things can go wrong. So now that all of these layers are covered, you can actually see the ingredients that you could combine into a recipe to create an entire infrastructure. So we kind of know what we want. We have the pieces here. We need to make the connections between them. The infrastructure as code concept, as I described it before. There are tools that do that. Like you're writing the code, but the tool specifically connects to the cloud and applies the code that you have. We're using Terraform most of the time. So this diagram is a good example of the eventual setup, eventual AWS infrastructure that you would like to have. Note the pieces that have the Helm icon. Those are inside of the cluster, and the Helm is basically a package for Kubernetes. So we're wrapping every little component into its own package and deploying it there. Another cool fact is that the way you see it right now is the setup for a single account. Imagine this is your production, and you would most likely love to have a development environment as well. And this can be replicated using the same idea of infrastructure as code. You have the same code, just applied to a different AWS account, and maybe slightly tuned configuration so it's smaller, so you don't have to pay the same money you pay for the production for development. Getting to all of this for a seasoned DevOps engineer is probably not a big deal. Like coming up with the whole idea, thinking through, thinking ahead for the needs of a specific application. Implementing this takes quite a lot of time and effort. In fact, we've had plenty of iterations in different projects where we had to evolve the pieces to the state that you can see in this diagram and generally in a good production system. So while doing so, we started separating different components into different code pieces with Terraform and created our own library of solutions. So our solutions library is basically a collection of my apologies. Experienced short technical difficulties. I'm back. Hopefully you guys hear me.
Yeah, thanks, Dennis.
Yeah, this is what happens when you refresh the wrong tab. Yeah, I'll be taking over a little bit of the screen to show you what I got here about the library that I was talking about. So we have all of these components as states of the infrastructure described as code that can be applied to virtually anywhere. And we have them not just for AWS. The next logical step was to, well, get them combined together into a setup that closely resembles or actually represents the diagram that you see right now. So we thought of it first again as boxes, and we got this blueprint that we call now Infrasnap. in different variations depending on the project needs. So the smallish, for example, would need a package like this with only the main necessities for the app. The cool thing here is that once you purchase, well, I have the account that I've already purchased this one. You get all of these components, and you can download them as a package to put into your GitHub, for example, GitHub repository. There's just a single config file that is required to manage everything else. Without that, our Infrasnap has to address the main need of the company that comes to us asking for assistance with the new infrastructure. They come to us saying, is tomorrow too soon? And before we had to say probably yes. Today, I'm going to prove you that no, it's not too soon. We can do it within it. In fact, before we started this meeting, I started the pipeline with the code that you just saw that was deploying this to a newly created AWS account. First of all, I would like to showcase this kind of configuration. So the thing that mostly discourages people from going with infrastructure as code is either I have existing engineers, they're great at what they do, there's just one problem, they will have to learn this new tech. And along the way, they have to learn the ropes of AWS, or the cloud generally. So we thought, how about we present the entire setup in the way of, like, you have to complete a single configuration file, like a survey, basically. Here, you can see here. And you don't have to know the code to do the rest. However, if you do know the code, nothing stops you from extending and building on top of it. There's the big thing in Corewide, generally, that we believe in the quality and the things that come with it. And for us, quality is also being able to let the customer, the client, do what they want with the things that they got. So first of all, it means once you got the Infrasnap from us, it is deployed by our engineers or with you together. You got the warranty period to check things out, but it's yours. You don't have to follow us as a vendor. You can take it to your team and build on top of this, because at this point, you already have the production setup that is working for you. And what you do with it next is up to you. But we cannot just let you go out there thinking that hopefully you will make it work. We give you the docs on top of it. Documentation that describes all of the infra that Infrasnap creates, the things that you should be careful of, and generally tries to guide you. So maybe this is mentoring me talking. I'm teaching folks DevOps, and it shows, I guess. But we're trying to educate your devs, your company, your team about how to handle the infrastructure, because you're the ones actually owning it. So whatever happens, you can always be sure that you can take over and you can improve on top of it. So the key parameters are here in the Infrasnap YAML. Note how we can define different environments in the same file with the same configuration. So right now, this file has only the production environment and all of the parameters related to it. Here is where we have the Kubernetes information. We also have the database engine that we're going to use, Postgres version, and all of that. We can enable the clustering, various pieces that are necessary, but you don't have to code them. They are here in the config. You just change the value and you let the things apply. What about applying them? So you can see 45 minutes ago, the code was pushed to this repository and this pipeline got triggered. And this pipeline created all of the resources from the diagram that you see right there in our AWS demo account. So I'm going to quickly go through AWS pieces that it got created before we will try to, well, simulate an actual app deployment to this infrastructure, because let's face it, it doesn't worth anything to have the infrastructure if you don't have an app to run in it. And the whole goal is to get your app to release in production. So as I said, networking wise, yeah, this happens. Networking wise, we start with VPC. So I have the list of VPCs right here in Frankfurt region. And there's one default, should be created by AWS for us, unnamed. And then there's Infrasnap demo production, the one created by the package. So you can see it's there. It also has the resource map. And these are all the subnetworks that I talked about. So the ones marked as public, they only hold the load balancer and allow the traffic from outside. And the private ones are used by the services in AWS, the cluster, the database, speaking of which, the database. Yeah, sign me back in. The database, as you can see, the instance is one. So we have the Postgres created here, and it's running in exactly the same subnet that we used. So this is the VPC that we created and 3 subnets, 3 for the high availability. So in any case, if something happens with one of them, the other can take over the connectivity. That's 3 buckets. Same thing again. We should have 2 buckets here. One that remembers the state of the infrastructure for Terraform, and the other one is where your application would store it. Then we go to the secrets. Yeah, I should have refreshed all the pages. Anyway, secrets are here. So each secret is created with the unique suffix. So in case you have to tinker with them, they will not be duplicated if necessary. So all of the data that are necessary for the app, they get created here. The MongoDB, by the way, is a stub. It's nothing used. It's just a placeholder for when we actually need to put some sort of credentials in there. And the big guy here, the Kubernetes cluster. The cluster, yeah, created an hour ago. No, not really an hour, 40 minutes. Yeah. What it does, it has in the compute, it has 2 nodes, 2 virtual machines. One belonging to the maintenance node group. This is something that we always create for things that aren't related to the application. So the monitoring goes there, all of the autoscaling pieces. Why? Because we want the app resources to be fully isolated from everything else. You wouldn't really want in your production for something else to take the resources away from your app. There should be no resource conflict. The app just runs and has the entire machine and all of its resources to itself. No hindering the performance, because this is the user experience. So we have a separate node group with separate definitions for the autoscaling for the app and the other for the maintenance. Now that we have all of the resources here, I think it's time for us to run the actual deployment, to showcase something. I needed a guinea pig desperately. So I thought, hey, what is the popular open source software that we can take and deploy to our newly created Infrasnap cluster to act as an app for the production? A lot of startups use Nodemation. You probably an A10. It's a really cool automation engine that allows you using like spread language from the little pieces. You can create the automation events. You can make things connect with hooks between different things. If you ever worked with Zapier, this is basically it, just free and open source. Again, no affiliation, but the guys are good and the software as well. So we thought, how about this? Since the Infrasnap comes with the helm.
Dennis, sorry to interrupt here. Just so you know, we have 4 more minutes left, and we have a few questions on the chat. So, so happy to do this test.
I will wrap up within a minute. Yeah.
Okay. Amazing.
So we decided that we'll take Nodemation, we push it to the repository, we add one configuration that is provided by Infrasnap for the app deployment specifically, and we're going to have this domain acting as the target for our Nodemation. So I'm going to do this first. See, there is no app at the moment running. So I'm hiding this. I am going to deploy the app and see that that link starts suddenly working, and we'll be able to see Nodemation. So while it is there, while the pipeline is running, I can probably go through those questions and answer them one by one, hopefully. And yeah, guys, if you feel like unmuting yourself and asking questions by voice, no problem with that. Aziz, however, I would like your assistance to read me the questions because due to
Of
me
course.
getting thrown out, I don't see the chat anymore. Sorry.
Yes, happy to start reading the questions. We have a question
Thank you.
from Namdi. She's asking if the AWS Secrets Manager for storing all the users' passwords is it for storing all the users' passwords is in, and then I imagine they are salted and hashed. And she's also asking what are the reasons to have multiple copies of the Docker container.
Okay, thanks for the questions. So the first one, uh, short answer, you can use them for the passwords. I wouldn't recommend to. The whole point of the secrets manager is to store sensitive configuration data for the app. So this is something that the app will consume at runtime once it starts, and then uses it for its operations. So you wouldn't place the passwords there, but the hash and the salt that you use for those passwords, you can store them in the secrets manager. So it's kind of a little bit different level. As for why we need multiple Docker containers, mostly for proper scaling and the upgrades. Think about this. You have one app. You're starting to update it. How will it work? You kick this app, you bring up another copy of it instead of this one. That moment where you have to destroy the old one and bring up the new, this is where the disruption happens. The connections that come within this time will not be handled. So you would want instead to bring the second copy, wait until it's healthy, redirect the traffic there, and then kill the first one. But when you have plenty of load right away, the new app will probably choke on a lot of connections coming at once. So what you would ideally want is the load to be properly distributed between multiple copies of the apps. And if something happens to the machine that the app is running on, you always have like one of 10 dies, you always have 9 others that will immediately take over the traffic for the rest because they already do. So this is the basics of high availability effect. Thank you.
Thanks, Demis. I hope Namdi, that answers your question as well. Yes, so we may have time for one more question, guys. So if you found this valuable, please ask us a question here, and I'm gonna try to ask it to Dennis in the time that we have
As
left.
the famous marketing quote says, your app could be here. Yeah, so this is how it would look like. You click one thing in the GitHub interface and it deploys your app, and then you access it by the domain that you prepared in advance. So the automation here is just the guinea pig that I used. A good guinea pig nonetheless, but serves pretty well for the traction example.
Amazing, guys. Just so you know, after the masterclass, I'm also going to be sending you the link to start the conversations with Corewide and the team with Dennis, in case this is something you'd be interested in claiming. Dennis, I believe you have a special offer for our community here. So if you could tell me more about it, that would be helpful.
Yeah, you saw the Infrasnap, you saw the product. Let's get together, let's have a call, let's discuss how we can apply the infrastructure to your specific case. Infrasnap is made to be the Kickstarter for your application, the accelerator. However, it's not the only thing that you'll probably need. You will need some sort of optimization, maybe individual changes, or you can take it right away. But the point still stands is we're not going to just blindly give you some sort of product that you would hopefully get a grasp of and work with it. We'll help you, we'll teach you, we'll deploy it for you, and we will hopefully be the vendor and the partner that you need on your infrastructure journey. So yeah, the special offer is there through the QR code. Please feel free to scan and book a call.
Yes, thanks a lot, Dennis, for that. Also, after the masterclass, I will be sending you guys an email if you want to have the link to this to the QR code here to claim this offer as well, or if you want to have a conversation with Dennis and the team in case this is helpful. Yeah, so thank you all for attending. Hope this was helpful. Thank you so much, Dennis, for doing the presentation.
Thank you for
Definitely
hosting us.
very valuable. Yeah. Thanks a lot, Dennis. Thanks, Alexandra and the team at Corewide. Cheers. Thank
Bye,
you.
everyone.
Bye bye.